Good morning and good afternoon, RSGA STEM class, and whoever decided to watch this video. And welcome to Lesson 6 on STEM Around Us. Let me ask, why do you think things fall instead of go up? Why do astronauts float in space? Why does the moon orbit the Earth instead of just flying away? The answer to all of these questions is gravity, the invisible force that holds the universe together. Today we're exploring the most important force in your life, the force that affects literally everything with mass in the entire universe: gravity. Here's the simple fact. Every object in the universe that has mass is attracted with gravity to every other object that has mass. You're gravitationally attracted to the Earth or the Earth's core, and the Earth is gravitationally attracted to you. You're even gravitationally attracted to the person sitting next to you. But that force is so tiny, you don't even feel it. Gravity is always attracting, never repelling or pushing away. It never turns off, and it's been pulling on you since the moment you were born. Sir Isaac Newton figured out gravity as a conception over 300 years ago. He realized that gravitational force depends on two things: mass and distance. The more mass two objects have, the stronger they attract each other. But here's the twist. The further apart they are, the weaker the force gets. Double the distance and gravity becomes 4 times weaker. It follows the inversely square relationship. This idea explains everything from why apples fell and why planets orbit the sun. For a moment, let's consider mass. Earth has enormous mass, about 6 trillion kilograms. That's why Earth's gravity is so strong. The moon has less mass than Earth, so its gravity is weaker, only about 1/6 as strong. Jupiter has way more mass than Earth, so its gravity is much stronger. If you weigh 100 pounds on Earth, you'd weigh about 17 pounds on the moon, but about 250 pounds on Jupiter. Same you, different gravitational force. Distance matters too. The distance from the center of mass also affects gravity. Right now, you're about 6,400 kilometers from Earth's center. At the top of Mount Everest, you're about 6,408 kilometers from the center. And not much difference, really, but gravity is almost the same from where you're at now to the top of Everest. Here's the thing, though. Astronauts on the International Space Station are about 6,800 kilometers from the center of Earth. That extra distance weakens gravity just enough so that they appear to float. They're still being pulled by gravity, they're just in a continuous free fall. And speed might have something to do with that sensation. You want to know something that a lot of people get wrong all the time? Mass and weight are not the same thing. Mass is how much more matter is in something. It never changes. Your mass on Earth is the same as your mass on the moon. But weight is the gravitational force pulling on your mass. Weight changes depending on the gravity around you. That's why astronauts are weightless in space, and why they weigh less on the moon, and why they weigh more in Jupiter. There's more gravity, less gravity, less weight, but their mass is always the same. Engineers and architects have to design everything with gravity in mind. Bridges must support their own weight plus the weight of traffic, all gravitational forces that are pulling down. Dams have to hold back millions of gallons of water from being pulled downward by gravity. Skyscrapers have to be designed so that gravity doesn't pull them over in the wind. Every building, every structure, every design must account for gravitational force. To ignore gravity when designing simple structures, well, that's a problem and will most definitely cause a collapse of the structure. Want to know about the secret of going into orbit? Satellites and planets are actually falling. They just keep missing the ground. Here's how it works. Gravity pulls on a satellite and it pulls it towards the Earth. But the satellite is also moving sideways really, really fast. It falls towards the Earth, but because it's moving sideways and so fast, it misses. And it keeps falling and missing, falling and missing. Well, that is orbit. The moon orbits the Earth in the same way. It's always falling towards the Earth, but it's moving so fast, it never quite hits it. Quite crazy, if you ask me. Thinking about STEM careers, gravity has to be accounted for in almost every STEM career. Civil engineers design roads, bridges, and tunnels, all things that have to fight gravity. Aerospace engineers calculate trajectories for rockets and satellites using gravitational ideas with their calculations. Architects design buildings that can stand strong against gravitational forces and other elements. Even construction workers and heavy equipment operators work with gravity every single day. They move things, they lift things. Understanding gravity isn't optional, it is absolutely essential. Well, this brings us to the end of this particular lesson. Make sure you look out for lesson number 7 as we start looking at Rube Goldberg machines. Now, that's some really cool stuff right there.